We present StableHand, a quality-aware flow matching method for world-space dual-hand motion estimation from Egocentric video. Recent advances in robot manipulation have scaled dexterous and bimanual skills by learning directly from egocentric human videos. These methods all rely on the same upstream signal, the world-space 4D motion of the two interacting hands. However, recovering this signal from egocentric video remains a fundamental bottleneck. Two challenges dominate. First, coupled head and hand motion causes either hand to leave the camera frustum for many consecutive frames. Second, persistent hand-object interactions during dexterous bimanual manipulation introduce severe, asymmetric occlusions of one or both hands. We propose StableHand, a quality-aware flow matching framework for world-space 4D dual-hand motion. Given an egocentric video, two frozen off-the-shelf modules extract per-frame inputs. A hand pose estimator produces per-hand camera frame mono observations, visual features, and hand confidence flags. A 3D geometry model produces per-frame camera poses and scene geometry tokens. The predicted camera pose then rigidly transforms the hand observations from the camera frame into the world frame. A learned quality network takes the world frame observations, confidence flags, and camera poses, and processes them through a temporal transformer with a global aggregation token. It predicts a 4-channel quality signal, rating the wrist translation and finger articulation of each hand at every frame. This quality signal is broadcast onto every motion channel and drives a conditional flow matching DIT through 4 coupled mechanisms. First, upper channel forward schedule replaces the standard scalar noise level. Each channel is noised at a rate determined by its own quality. Second, a quality-adjusted velocity target freezes high-quality channels at 0 velocity while regenerating low-quality ones from noise. Third, AdaLN modulation inside the DIT conditions every block on the per-frame quality signal, scaling wrist and finger updates to match the per-channel structure. Fourth, a quality-aware initialization at tau equals 0 anchors high-quality channels near the world frame observation and starts low-quality ones from pure noise. A single ode integration from tau equals 0 to 1 then yields the world space 4D dual hand motion. We now show qualitative results of StableHand on egocentric videos. Throughout the sequence, the hands move quickly across the workspace or frequently leave the camera frustum. Even under these conditions, StableHand produces a continuous and stable world space trajectory. The wrist positions stay anchored to the global scene, and the finger articulations smoothly follow the underlying grasp, with no visible drift between visible and missing phases. The same behavior carries over to dexterous bimanual manipulation, where the two hands stay in persistent contact with an object and one of them is heavily occluded for long contact phases. StableHand instead routes the per-hand quality signal through a shared self-attention over both hands, so that the visible hand stays anchored on its clean observation while the occluded one is regenerated coherently with it. The two hands remain consistent in their relative position throughout the contact phase.